Hi friends. So in this video I'm going to explain about classification of systems. So last video we have seen what is a signal and what is a system. System is nothing but it a set of elements or a functional blocks that are connected together to produce an output in response to an input signal. So system is nothing but here there is a system. So this is a system. So which is having the input response x of t and the output response is y of t. So this is a system. So here these are the different classification of systems. The first one is static and dynamic system, linear and non-linear system, causal and non-causal, time variant and time invariant systems, and the last one is stable and unstable system. So let us see the first classification, that is static and dynamic system. Here the static system is also called as a memoryless system. Here this is a memoryless system. So why we call it as a memoryless system? That means here the output at any instant of time depends only on present input value. That means it only depends on present values. It does not depends on any future or past values. Based on that, this system we call it as a memoryless system. Because of there is no past values, this system only depends on the present values. We call it as a memoryless system. So here dynamic system is nothing but memory system. Why? Because the system its output at any instant of time which depends upon past and future values. So this is past and future values. So let us see one example, some examples on a static and dynamic system. Here y of t is equal to 2 into x of t. So we have to find whether the system is a static or dynamic system. So if you take any instant of time means you have to take t is equal to 0, t is equal to 1, t is equal to 2 at any instant of time. So that means t is equal to 0. That means if you substitute t value here as 0 and t 2 into x of 0, that means the output which depends on the present input value. Here this will depend on the present input value. If you take a second instant, that is t is equal to 1, then y of 1 is equal to 2 into x of n. So based on this example, the system which depends only on present values, hence the system is static system. So let us see other example, y of t is equal to x of 2t. So here at t is equal to 0, if you take some instant, substitute some instant value at t is equal to 0, t is equal to 1, t is equal to minus 1. So verify y of 0 is equal to t into 2 into t. Here the t value is what? 0. Next t is equal to 1. Y of 1 is equal to x of 2. Then t is equal to minus 1. Y of minus 1 is equal to x of minus 2. So here minus 2 is a past value and here this is a future value. That means how to find whether it is a past value, present value and future value. See, this is 0. The left side values are negative values, we call it as past values. And 0 is the present value. This is an example. And 1, 2, 3, 4, all these are positive values. So we have to take it as a future values. So here it depends only on past and future values. So here there is a present value. So you have to verify the number of instants. So if you take t is equal to 2, if you substitute t is equal to 2, y of 2 is equal to x of 4. Again it depends upon future value. Then t is equal to 3. It depends upon future value. So based on the number of instants it satisfies, depends on that we have to find whether it is a static or dynamic system. So this is a dynamic system. So the next classification is linear and non-linear systems. So linear systems are nothing but it satisfies the superposition principle. Superposition principle. So that is nothing but here the weighted sum of the signals, which is equal to the corresponding weighted sum of the each of the individual input signals. So here the two signals x1 of t and x2 of t. So here the total weighted sum of the signal, which is equal to the weighted sum of the individual inputs. So here the system which satisfies the linear systems. So LHS is equal to RHS, then it is a linear system. If LHS is not equal to RHS, then it is not a linear system. So let us see one problem on linear system. So here y of t is equal to t into x of t. So what is LHS side? Left hand side, this is LHS side. That is what? A into x1 of t plus a2 into x2 of t. So this is LHS side. So what is the system given in the problem? T into x of t. So system is what? H. So t into a1 x1 of t plus a2 x2 of t. Now multiply t on these sides, x1 of t and x2 of t. So you are getting this value. So now in the same way, if you have to take RHS side. So what is RHS? A1 into h of x1 of t, h of x1 of t plus a2 into h of x2 of t. Here what is the system given? That is t into x1 of t plus a2 into x2 of t. Now compare, this is LHS and this is RHS. So now if these two are equal, then it is a linear system. Now let us see one more problem. See, y of t is equal to x square of t. That means LHS is what? Write down the LHS equation. Now what is the system here? X square of t. That means this is the total value, you have to square it. That is the system, x square of t. Then what is RHS? Individual weighted sum of individual response signals. That is A1 into h of x1 of t. Here system is what? x1 square of t plus a2 x2 square of t. So here this one is RHS and this one is LHS. LHS we are getting the whole square. Here is what? Square, x1 square plus x2 square. Here these two are not equal. LHS which is not equal to RHS. Then the system is called a non-linear system. Third type of system is what? Causal and non-causal system. Here the causal system are nothing but the output of the system at any instant of time depends on present and past inputs. So here it depends on present and past inputs are called causal systems. If the system which depends only on future inputs, then it is called non-causal systems. So in static and dynamic system, static system only depends upon the present input values. Here the causal system which depends upon the present and past inputs. Let us see one example here. Y of t is equal to x of t minus x of t minus 1. So if you substitute any instant of time, I am taking t is equal to 0. Then y of 0 is equal to t value is what? 0. X of 0 minus x of minus 1. Here I am taking 0. We are getting the present value. Next one is what? Minus 1. Minus 1 is what? Past value. So present and past. Now if you substitute one more instant at t is equal to 1, y of 1 is equal to what? X of 1 minus x of 0. So here 1 is a present value and 0 is a past value. So hence the system is causal system. That means the system which depends only on present and past inputs. Let us see one more example, that is y of t is equal to x of t plus 2x of 3 minus t. So let us substitute some instant values. T is equal to minus 1, y of minus 1 is equal to, here t value as minus 1 plus 2 into x of 4. Next t is equal to 0. Here y of 0 is equal to x of 0 plus 2 into x of 3. then t of 1 is equal to y of 1 is equal to x of 1 plus 2 into x of 2. That means, so if you are substituting, each depends only on future values, right? So this is a future value. So if it is only depends upon the, if you have to find out if it is depends only on future values, then the system is a non-causal system. So the next type of system is time variant and time invariant systems. So here the time variant systems are nothing but the input and output characteristic does not change with time, are called time invariant systems. It does not varies with time. Then x of t, if you give system, we can get y of t. X of t minus m, if you give it to the system, we can get y of t minus m. So m is nothing but it's a delay. So in time invariant system, so h of y of t is equal to h of x of t, then y of t minus m is equal to h of x of t minus m. So let us see, let us verify in a diagrammatic representation. I am taking here as x of t and here as a delay. After delay we can get a signal as x of t minus m, then give it to a system h, we can get y1 of t. Now if take other one, that is x of t, give it to a system, then apply a delay, so you can get y2 of t. If y1 of t is equal to y2 of t, then it is a time invariant system. If y1 of t is not equal to y2 of t, then it is a time variant system. So let us see some problems on time variant and time invariant systems. So those are, so the first one is what? Let us take y of t is equal to 2t into x of t. So we have to find whether the system is a time variant or time invariant. Here x of t signal which is given to a delay, we can get x of t minus m and then apply to a system. What is system here? 2t into x of t. Then this system we are getting y1 of t is equal to 2t into x of t minus m. So we are giving the delayed version which is given to a system, that is x of t minus m. Other one is what? X of t applied to a system. What is system here? 2t into x of t. So that is 2t into x of t. Apply a delay. You have to apply a delay to this whole one, that is 2 of t minus m. That means in place of t you have to substitute t minus m, and here is x of t minus m. So we are getting this one. So here f1 of t, observe f1 of t and f2 of t, here these two are not equal, hence the system is a time variant system. Let us see one more problem, that is y of t is equal to x of t plus c. So in the same way, x of signal which is given to a delay, we are getting x of t minus 1, then apply to a system. What is system here? X of t plus c. So in place of t you have to substitute t minus 1. Then x of t given to a system, we can get system as what? X of t plus c, then apply to a delay. Then we are getting y of t is equal to x of t minus m plus c. Then y1 of t is equal to y2 of t. Then the system is time invariant system. And the last type of signal is stable and unstable systems. Stable and unstable systems. So stable system, which is nothing but a system is said to be stable, it satisfies BIBO condition. BIBO is nothing but bounded input and bounded output. That is nothing but finite input and finite output values. So here what is the condition for stability of an LTI system? LTI system is nothing but a linear time invariant system. The system which satisfies the linearity property and time invariant. So for this type of signals we have to find the stability. That means The time invariant systems are nothing but what? The system which does not varies with time. So it does not varies with time means it is in stable condition. For that type of signals we have to find the condition here. So this is the condition of stability, that is nothing but integral minus infinity to infinity mod h of t dt less than infinity. This is the impulse response. Now let us see one problem on this one. We have to find whether the system is stable or not. So given system h of t is equal to e power minus 5 of mod t. So for stability you have to find out, you have to take this equation, that is integral minus infinity to infinity mod h of t dt less than infinity. So in place of h of t substitute this value. Okay, so now e power, remove this mod, you can get e power minus 5 mod t into dt. So then this is of mod, because of mod t here, so here you have to separate the integrals from minus infinity to 0 and 0 to infinity. So minus infinity to 0, here the value is e power 5t into d plus e power minus 5t, integral 0 to infinity, the value is e power minus 5t into dt. Then integrate it. So integrate these two. So you can get these values. Then substitute upper limit minus lower limit. So now here e power 0 value is 1 minus e power minus infinity value is 0. E power minus infinity value is 0. Minus into minus plus, e power 0 value is 1 by 5. So we are getting 2 power 5. That means constant. So it satisfies the BIBO conditions, right? That means if we are getting some finite value, then the system is stable. Because of constant value only, the stability, we are finding the stability. Okay, so this value is less than infinity. Let us see one more problem, that is h of t is equal to e power 4t u of t. Then write down the condition, then substitute the h of t value here. Then if you remove u of t, then you have to change the limits from 0 to infinity, that is e power 4t into t. That is equal to e power, integrate it, e power 40 divided by 4, and the value is 0 to infinity. So here e power minus infinity by 4 minus e power 0 by 4. So we already know e power minus infinity value is 0 and e power infinity value is infinity. Then infinity minus 1 by 4 value is what? Infinity. So here that means this is not satisfied the condition, we are getting an infinite value, that is it is not less than infinity, we are getting infinity. Then the system is unstable.